Hey there, DevOps pros and cloud enthusiasts. Welcome back to GogoGinni's Tech Talk. Today we're diving into distributed tracing. How do companies like Netflix and Uber handle millions of requests? The secret is seeing inside their complex systems. They use distributed tracing. Follow a user's request through your application. We'll break down what distributed tracing is and why it's a game changer. In the world of software, things can go wrong, especially in complex systems. That's where observability comes in. It's like a superpower that lets you understand your applications from the inside out, knowing what's happening, why, and how to fix it. Distributed tracing is key. Follow requests through your system, revealing bottlenecks and errors. Optimize performance, improve reliability, and deliver a better user experience. Before we dive into distributed tracing, let's unravel application tracing. Imagine a simple web application. A user logs in. Tracing follows their request like a detective. You see it travel through your application. This map shows called functions, operation times, and potential roadblocks. Let's break this down with an example. Imagine a user wants to view their order history. When they click the button, a get orders request is sent to your server. The web server receives the request, fetches order details from the database, and renders the order history page. It connects these steps, revealing dependencies and data flow. The order history page is loading slowly. Tracing helps pinpoint the culprit. It could be a slow database query, network delay, or a bottleneck in your application code. Analyze timing data to find the longest step. This visibility is crucial for optimization and debugging. Tracing helps us understand requests within a single application, but applications are rarely confined to a single service. Welcome to the world of microservices. Imagine your application as interconnected services, each with a specific function. This architecture brings flexibility and scalability, but also complexity. If an error occurs or a request slows down, how do you pinpoint the issue? Traditional tracing won't cut it. Distributed tracing saves the day. It acts like a universal translator for microservices. Follow a request through each service, creating a unified view of its journey. Let's take the example of Netflix, renowned for its microservices architecture. When you hit play, your request interacts with hundreds of servers. Distributed tracing lets engineers follow each request across this complex web. They see which services are involved, how long each step takes, and potential bottlenecks. This visibility is crucial for Netflix's seamless streaming experience. To grasp distributed tracing, understand its place in observability. Observability has three pillars, each offering a unique perspective. First, metrics give a high-level overview. They tell you if something is wrong, but not why. Next, we have logs, the detailed records of events within your application. Logs are invaluable for troubleshooting. They provide context to understand why an error occurred or what led to a behavior. In a microservices environment, logs can be overwhelming, scattered across services. Metrics and logs are essential, but they only paint a partial picture in a microservices world. Imagine diagnosing a complex machine by looking at individual gauges and warning lights. Without understanding component interactions, pinpointing the root cause is difficult. That's where traces become indispensable. A user experiences a slow checkout process in your e-commerce application. Metrics show increased latency, and logs reveal errors in payment processing. This is where traces shine. Follow the trace to see the user's entire checkout journey. Now that you understand distributed tracing, let's talk tools. Just like a detective needs the right equipment, you need the right tools to capture and analyze traces. One popular choice is Jaeger, developed by Uber. Jaeger is scalable and has an intuitive interface. Jaeger is like having a dedicated detective on your team, tracking down every clue. It captures traces from your applications and provides tools to analyze and visualize the data. Use opentelemetry to instrument your code and send trace data to Jaeger. Opentelemetry is the language Jaeger speaks, collecting data from your services. While Jaeger is a fantastic choice, it's not the only player in the distributed tracing game. Other options include Zipkin, another open source system, and AWS X-Ray, a managed service by Amazon. Zipkin offers a straightforward setup process. AWS X-Ray is tightly integrated with other AWS services, ideal for AWS-hosted applications. The best tool depends on your needs, tech stack, and budget. For a powerful open-source solution, Jaeger is excellent. If invested in AWS, X-Ray is seamless. Evaluate, experiment, and choose the best tool for your goals. Alright folks, let's get our hands a little dirty and set up Jaeger in a real-world project. First, we instrument our code. This involves adding snippets to our application to capture and emit tracing data as requests flow through our system. We'll use opentelemetry, our trusty sidekick. Opentelemetry bridges your application and Jaeger. It intercepts requests, records timestamps and operation names, and sends this data to Jaeger. Opentelemetry is vendor agnostic. Switch between Jaeger, Zipkin, or others without rewriting code. Now that our application is instrumented and sending data, we need someone to receive and store this information. That's where the Jaeger backend comes in, the heart of our tracing operation. Think of the Jaeger backend as our detective's headquarters, where clues are gathered, analyzed, and stored. It consists of several components working together to ensure efficient trace collection and visualization. The Jaeger collector receives traces from multiple agents, validates them, and stores them in a durable backend. This could be an in-memory store or a distributed database, like Cassandra or Elasticsearch. Jaeger offers flexibility in choosing the best storage backend. Once the trace data is stored, Jaeger's processing pipeline starts. We've laid the groundwork, explored the tools, and set up Jaeger. But with any powerful technology, distributed tracing has its challenges. One challenge is instrumenting applications in different languages. Opentelemetry helps with its language-agnostic approach. Ensuring trace context is properly propagated across service boundaries is crucial. Each service must pass a unique identifier, linking its trace to the larger picture. This is done using headers in requests between services. These headers contain the trace ID, span ID, and other relevant information. Let's address the elephant in the room: performance overhead. Capturing and transmitting trace data comes at a cost. The solution: sampling. Configure tracing to sample a percentage of requests. This reduces overhead while providing valuable insights.
7, 6, 5, 4, 3, 2, 1.
You'll never have the sacred stone.
Section 4. Safeguarding sensitive information. Masking and sanitization. Ensure we're not exposing sensitive information through traces. Imagine our detective revealing a witness's identity. Not good. Mask or sanitize sensitive data, like passwords and credit card numbers. Jaeger provides mechanisms for data masking and sanitization. Define rules to redact or replace sensitive data. Keep your traces secure and compliant. Section 1. Maintaining context. The key to unbroken traces. Let's dive into maintaining context in distributed tracing. Imagine our detective following a suspect switching vehicles. They need a way to keep track. In microservices, requests hop between services like that suspect switching cars. Each service must pass a unique identifier, a digital baton, linking its part of the trace. This is handled using headers within the requests. Headers, the unsung heroes of trace propagation. These headers, like tiny breadcrumbs, retrace a request steps across the application. They include trace ID, a unique identifier linking all requests and operations in the same user interaction. Span ID. Each operation, like a database query or API call, gets its own span ID. This helps us understand the sequence of operations. Parent span ID establishes the parent-child relationship between spans. How do we ensure these headers are passed along reliably? Many frameworks and libraries offer built-in support for distributed tracing. For instance, Spring Cloud for Java can automatically intercept requests and propagate headers. In a bare-bones setup, you might need to handle propagation manually. Don't worry, it's not as daunting as it sounds. Once you've set up context propagation, validate that everything is working as expected. Inspect network requests using developer tools or a network monitoring tool to check trace context headers. Add logging statements to print trace context headers at various points in your application flow. Ensure correct context propagation to empower Jaeger, providing end-to-end traces that reveal the complete journey of a request. Let's appreciate how distributed tracing translates into real-world success stories. Uber uses distributed tracing to handle millions of requests every hour. They track a ride request from the moment a user taps their app to the final destination. This helps pinpoint bottlenecks and ensure a smooth experience. Netflix relies on distributed tracing to keep movies and shows playing smoothly. It helps them diagnose issues instantly and keep the entertainment flowing. The takeaway is clear. Distributed tracing is a game changer. It helps quickly identify the root cause of issues, minimizing downtime and keeping systems smooth. Bottlenecks become obvious, allowing teams to optimize performance. With a clear understanding, companies can confidently experiment, knowing they can monitor and troubleshoot effectively. Now, you might be thinking, that's great for giants like Uber and Netflix, but what about my business? In today's digital landscape, observability isn't just a luxury, it's a necessity. Whether you're a startup or an enterprise, distributed tracing helps build resilient performance applications. Equip your teams with insights to deliver exceptional user experiences and stay ahead. So, what are you waiting for? Take the first step towards unlocking the power of observability. Experiment with distributed tracing and empower your teams to build resilient applications. Thank you for tuning in to GogoGinni's Tech Talk. Don't forget to subscribe for more tech insights. Until next time, happy tracing.